Okay, Assalamualaikum and good day everyone. In this video, I'm going to continue with the subtopic current in electrostatic in medium chapter, where previously you already learned the first model of the current. So in this video, we are going to continue with the second model and the third model of current. How can we relate I and J? So this equation I equal to the integration of J dot ds give the relationship between I and J, and this will be our second equation of current. And here is, you notice that J is a vector while I is a scalar, and this I is a conduction current, where the medium for this current is a conductor. Okay, in the previous video, I shared with you a convection current, where in the equation of the convection current, it doesn't mention any medium. Okay, so that's the difference between the conduction current and the convection current. Okay, we already know first and second model of current. Now we are going to proceed with our third equation. So let's say we have this Q charge, and this charge is enclosed by this boundary. Okay, and because the charge is a movement charge, I can consider that the charge will move from this area to this area. Okay, it will go out from this enclosed area to the outside this boundary. Okay, so inside this boundary, okay, I can say that this cloud of charge is containing this Q enclosed. Okay, so let's take a look the total current at this boundary, okay, or at the surface of this cloud charge. So this one, okay, I can write as a total charge or total current at the boundary is equal to the closed integration J dot ds. Okay, this is a closed integration because we want to find all the charge inside this cloud charge. Okay, so this is our first equation to find all the charge inside this boundary. And the second way to find that total current, we can consider the movement of the charge from here to the outside as a decreasing value of charge. So if we observe the current inside the cloud, we can write another equation of I, where I equal to the rate of charge decreasing. Okay, so this is another equation that we can find the total current in this boundary. So I can say that this equation and this equation is same. The difference is only where we observe the total current. This one we observe the total current moving, this one is total current moving outwards, or it going out from this boundary, and at this boundary we find the charge enclosed by this boundary. So it's supposed to be equal. Thus, we can write the integration of J dot ds is equal to negative dq enclosed over dt. And this one is equal to negative d over dt integration of rho v dv. Okay, we continue with our equation, and I'm going to write it back here. Okay, the closed integration of J dot ds is equal to the integration of minus d rho v over dt. Okay, this one is dv. Okay, as you can see here that this one is the surface integration, while this one is the volume integration. Now what we want to do is we want to make it in the same platform so that easy to us to solve this equation later. So now I'm going to convert this surface integration into the volume integration. With that, we need to use the divergence theorem, because the divergence theorem gives us the conversion between the surface and the volume integration. So from here, we can write the volume integration, okay, J dv. Okay, is equal to the negative d rho v dt dv. So now to proceed, I'm going to take the inner part of this only. Okay, I want to take this inner part only. Okay, this is the integration, a process of changing integration format to a point format. So from here, we can write that this J is equal to negative d rho v over dt. And this is our third model of current. And this is known as the continuity current equation. With that, you already know the third model of current in the chapter of electrostatic in medium. So that's all for this video. Thank you.